Hello, hello, hello. Welcome to the Fundamentals of Programming. Today we're going to be covering the basics of Python. So we're going to cover a lot of things today, actually. The basics sound pretty basic, but there's usually a lot that comes along with it. So today we're going to be talking about how you can actually print things out for an output on your actual module that we'll be using, how you can input data, how you can input your variables and values and things like that, how you name and identify variables so that you can, use them later. As well as things like the data types that your values might have, which is going to be very important for when we try to do some operations that we will do at the end of this video. Again, so we're going to be covering a couple things here: the basics of inputs and outputs, data types, variable identifiers, and the basics of operations, as well as a little bit on data type conversion. So 5 big topics today. Again, these are the Python basics. If you can watch this video multiple times, but we're going to try to cover a lot of things today. Okay, so let's go ahead and go to our Python little programming IDE here. All right, I'm going to be using the REPL-IT online IDE, their little compiler they have. It's pretty nice. I can type over here, type my code over on the right here, and then I can go ahead and run it on the output over here, and I can see everything. Again, this is kind of a really nice online tool. If you want to use it, I recommend it. There's also things you can download. I, though, like to use some of these online IDEs just because for what we're doing right now, it's pretty much all I need. So let's go ahead and try to write a first little script here. Let's the classic hello world, except for let's put a little spin on it. So there's a function in Python called print. Now with this function, it's just going to print that whatever we tell it to print over on the right here. So if I hit run, it's going to print hello. So I recommend maybe you code along a little bit here. We can kind of print a couple things. Print hello, how are you doing? And see, those are on 2 separate lines because they're 2 separate prints. If I were to instead take how are you doing and put it here, it's going to be on the same line. See, it's on the same line. I did 1 print. So if I can do multiple prints, I can count if I want to. And notice I'm putting things in quotations. Now the reason I'm doing that, let's see what happens when I do 1 without quotations. So the print's the same thing. The difference here is what we'll call the data type, right? So things inside of quotations are going to be known as strings. Things outside this 1 would actually be an integer, and we'll cover those data types here in a minute. One thing I want to show you that's kind of interesting is if we print, let's say we want to print 2 million, and I'm printing it as a string this time, but let's see what happens if I print it as, with the commas, as a number. See the difference here. So notice right here, 2 million is printed out and it's 2 million. But when you go down here, it's 200. Now in Python, variables are separated by commas. So as you can see, I have 2, which is printed out, then comma 000, which Python is like, okay, well you don't need all those extra zeros. I'm just going to print 10 because that's the second variable. And then 3 is another 3 zeros, that third variable, and then that's this 0 here. Notice there's spaces in between, so Python thinks that those are 3 individual variables. So that's kind of an interesting little quirk, and we'll cover some of these little things about that. So when I put things inside of quotes, it is connecting them. They are a connected string, and it'll make a little bit more sense when we talk about strings some more. So I can go ahead and type a full sentence. Hello. Welcome to the basics of programming. Enjoy. I can type. Hit run. And notice it doesn't care about the commas or the periods. It just runs it all together as if it were one giant variable. That's different than if we do not put it in quotations where the commas make it separate variables. That's kind of the first point I want to talk about. Well, this is kind of cool. We're printing things out. We're getting the computer to talk to us. But let's go ahead and talk about variables and inputs and outputs, because we can actually do some cool stuff so that we can get the computer to actually talk to us in a much cooler way. So in Python, when we name a variable, it is known as an identifier. So it's like a keyword that we can use to store a value. Now there are certain rules when we give an identifier to a variable, and that is it must start with a lower or uppercase letter from A to Z or an underscore. You cannot start with a number or any of these characters like this. That will cause some issues. So again, lower or uppercase letter or an underscore. It also can contain no punctuation characters like the @ symbol, ampersand, percentage, or the hashtag. And it also cannot have any spaces in it, because if you put a space in there, Python will probably think it's two separate variables and it's going to get really confused. Also, if you try to name something with one of the reserved Python words like if, for, or list, or there's a big long list of all of the words that you can't use that are reserved for various functions and control structures, that will also be invalid. So let's go ahead and take a look at some of the, let's name some variables and let's get some inputs going so we can actually store some interesting data and actually have some fun here. Alright, let's take a look at some good and bad variable names here. So x is a great variable name. I can assign x as 10. I could assign y, also another good variable name, as 20. And then I can go ahead, and print x plus y very easily. Let's do that and see what works. And it prints out 30. Perfect. Those worked. Let's see what happens if I try to store, let's say I started it with, let's say my first variable. I named it first variable. Something, maybe this is my first variable and I wanted it to be 1. If I hit run, let's see what happens. So it says first variable invalid syntax. Now, the reason is because I put the number 1 as the first character in my identifier. That is never going to work. If I wanted to name this first variable, I could put an underscore before this, and now it will run. So notice it still prints out 30, and I still have this first variable. And then I could go ahead and do second variable, and add those two things together. And I don't know if I really want to type out first. Let's be lazy here. Plus underscore seconds, hit run, and then it prints out both of them. So notice I can use numbers in my variable identifier, but they cannot be the first character. Also, if I were to, want to store my first name here, and I put a space in there, let's see what you guys think is going to happen. It's probably not going to work, right? So let's say my first name was Bob. I hit run, and I get another invalid syntax error right here, just saying that there can't be a space. So I could put an underscore there again, and still saying Bob, because that's a string name. Bob is not defined, which means you can't store Bob as an integer or a floating point, obviously. So I got to do it as Bob, and we're good. Then I can print out first name, hit run, and it works. So really, underscores are a big help in a lot of these situations. Get used to using underscores; they will be your good friends. Let's go ahead and play around with a new little function that we're going to talk about, and we're going to call it, we'll call it input. So name equals input. It's a really nice function. So what you can do with the input function is Python allows you to input data as a variable for the value of that identifier. So when I say name equals input, whatever I input, if I hit run, it's going to prompt me to give an input. If I say that, now name is Devin. So if I were to print name and hit run, and then I were to say Billy Bob, it's going to print out Billy Bob, right? So this name variable is stored as this input. So we can go ahead and input anything we want, and it'll be printed out. So that's a really handy feature, and we're going to be using that here shortly. So just wanted to kind of show you guys that. You don't always have to, when you give a variable, it doesn't always have to have a hard value like x equals 10. You can have x equals or y equals input, and then say what, got to put this in quotations, what is the height? And then it'll run, and it'll ask name, right? So Devin, what is the height? And let's say 20, and then I could do stuff with that later. So if you're looking for feedback from a user on your program, you want to get inputs from that user, right? That's how you would do that. So I've been mentioning things like strings and integers and floats and all these things, and I know that hopefully you watched the video before this and you know what I'm talking about, data types, but I just want to go over the basic Python data types that are used, and there are 5 of them. So if we look at it, there's the integer, which you guys know about. It's the real valued whole number. The floating point, which is a number with a decimal point in it, so it's not a whole number, right? So that's the difference between a floating point and an integer. And be careful with those. That can come and bite you later. Also, there was a string, and we've been using strings a lot. It identifies a set of connected characters inside of quotation marks. So anytime I was using those inputs and I was asking questions, or I was trying to store names or words, I had to store it as a string inside of quotation marks. And that's really the key, is inside of quotation marks. Otherwise, it's not going to work. So other than that, there's the list, which is a compound data type that is made up of multiple items, and we'll take a look at that in a second. There's also things like the tuple, or the tuple, and it's like a list, but you store it inside parentheses, and once you set the tuple, it cannot change. So it's basically a static thing at that point. Then finally, there's the dictionary, and it's not like the dictionary you use to look up words. It's like a list, but each entry is made up of key value pairs, which is like a dictionary where you have the key would be the word and the value would be the description of that word. We'll be dealing with dictionaries and tuples later on in this course. However, for right now, go ahead and put those on the side, and we'll cover those later. You may be wondering how you can determine what your data type is. Now, I made this little, flow diagram here for you that you can look at and refer to. It's also going to be in your class notes, so you can take a look at it later. But basically, you can just ask yourself a couple questions, like, is the variable a number, word, character, or does it store more than one value? If it's a number, you can then ask, is it a whole number or a decimal point, and that'll tell you whether it's a float or an integer. If it's a word or character, just store it as a string. Don't worry about anything else. It is a string unless it's more than one individual sentence, right? Which that would mean it's more than one value, right? If they had more than one set of quotes is what I mean by more than one sentence. If there were multiple sets of quotes, it would be more than one value. And then you would have to go down this kind of more complicated branch of this flow diagram where it says, can the values be changed? No, it's a tuple. Yes. And then you ask, do the values come in pairs? If it does, it's a dictionary. If it does not, it is a list. So that's kind of a really quick, easy way to figure out what your data type is. It shouldn't take too long, and once you get more practice with it, it becomes pretty easy. Now, the next thing I want to talk about, which is really, really important and really convenient, is just data type conversion. So we are going to want to be able to convert between floats and integers and lists and strings and things like that. Because when you actually get noticed before when we were doing the inputs, we asked for an input from the user. That is actually stored as a string. Now, what's going to happen is if you wanted to perform, like let's say you were asking for the number, like the height of a building, it'd be stored as a string, which you can't perform mathematical operations on that. So you would have to convert that to an integer or a float using these functions. And we're going to take a look at that, an example of that in a second here. So these are all they're pretty simple. X is whatever you want to convert, and then the function is what you want to convert it to. So int x would be converting x to an integer. Float x would be converting x to a float. Str x would be converting x to a string, and so on. You guys get the picture. I did this little graphic here showing, you can convert between all of these, and you can cycle through depending on your needs. Before I go ahead and go back to the programming part, I want to just show you really quickly some of the arithmetic operations we can use. I already used addition, but you can also use like subtraction, multiplication, division, modulus, exponent, and floor division. And we're going to look at examples of each of these in just a minute here when I start programming again. But the reason I'm talking about data types is because data types determine what operators you can use on your actual variable. So if you are using a string, you can't actually divide a string, right? How could you divide a word by 2? You can't really divide a word by 2. It doesn't make sense. You can't, the same way you can't take an exponent to a list. Well, you can actually take an exponent to a list, but certain things don't make a lot of sense. So we're going to experiment around with some of these, and I'll show you guys some cool stuff that you can do with this and why data types are important. All right, so let's go ahead and go back to our IDE and go back to our compiler here really quick. All right, so we've got a number of different identifiers here and variables with various different types. So x equals 10, that's obviously an integer. And notice I used the pound or hashtag sign to comment on each line. And I really recommend that you get in the habit of just commenting maybe not every line, but every couple lines, just telling you what your code is doing. Like I could have at the top of here, instead of commenting each line, I could have said declare all variables and initial values, right? Because that's what I'm doing. But instead, for this purpose of the video, I did it every line. So I got a floating point here, 1.07. Again, that's with a decimal point. That's the difference between an integer and a floating point. I have a name here, which is a string, and that is Scipio, and it's inside of quotations. And that's really, really important that you put all strings inside of quotations. If I were to try to say name equals Scipio without the quotations, it's going to give me an error because, it has to be a string. You can't store words without having it inside of quotations. So remember that. Then I said Fibonacci equals this list, which notice it is inside of the square brackets, and it's each of the values is separated by commas. So that's a list. Then a little bit below, I had two inputs, length and width, and they're asking for the length and width of an object, and both of these will be actually stored as strings. So the length will be stored as a string. So let's go ahead and see what happens if I try to add a couple of these variables together. Let's see what happens if I add x plus y. Let's first see there. So x plus y, it's going to ask me for the length. Let's say 10, 10, and it says 11.07. So what's going to happen is that whatever I print here is going to be actually stored as a floating point. So if I were to say a equals, or let's say z equals x plus y, and then print, print z, and let's comment these out really quick for a second here. It's going to print 11.07. So z will then be converted to a floating point because two of the variables that were added together, one was an integer and one was a floating point. Python will automatically make z a floating point because one of the variables was a floating point. So if they were both integers, obviously it will stay an integer. But if you're adding an integer and a floating point, the result will be a floating point. So the same thing will happen if I do zx times y. It's going to give me another floating point, right? So when you're multiplying or doing any kind of operation between an integer and a floating point, it's going to give you a floating point. Okay? That's something to keep in mind. So let's go ahead and take a look. Let's see if I tried to, let's say I wanted double, and I'll say name times 2. Let's see what happens here. So, and then I'll print out that double. So let's see if we can multiply strings here. I'm trying to multiply Scipio by 2 and then print it out. Let's see what happens. So it just prints out Scipio, Scipio. So you can double or multiply strings. It just repeats itself, right? So I could say name times 4, and it's going to print it out 4 times. So if you want to really repeat something or drive somebody crazy, you can, multiply words by a lot of words and then get craziness. So that does work. Let's see what happens if we did divide by 4. Let's see what happens. So we can't divide strings. It says unsupported operand type for division, string, and int. So you cannot divide a string by an integer. It's just not going to work. I could maybe define name by name and see what happens, and see it's still, you can't divide strings by strings. So you can't divide things in a string, right? That doesn't make sense. How could you divide a word? That doesn't really work. So there's other things you can do, and we'll talk about that a little bit later, to grab specific letters from a string, and those are just little handy-dandy functions that we'll talk about later. Let's go ahead and play around with the list here. So let's say test, I'm just going to name it Fibonacci times 2. Now, go ahead and take a guess for a second what you guys think is going to happen. Is it going to be like a list, or is it going to be doubling the list, or like doubling each of the values, or maybe it will, multiply it, like have 2 of the same values like it did with the string. So let's see here. Print test, hit run, and it just doubles it and adds it inside of that list. So as you can see, it goes 1, 1, 2, 3, 5, 8, 13, and then it repeats that once again. So we could do that 5 times 5, and it's just going to repeat it 5 times at that point. So that's kind of nice. What happens if we did plus 5? Do you think that's going to work? No, it's not, because the reason for that is each of these has their own index, and we can't actually, add 5 to each of these without using some special syntax that we'll cover in a future video. If we wanted to add 5 to one of them, we could say x equals Fibonacci, and then we could say angle bracket x equals Fibonacci, and we want to add it to the first one, we would say x equals Fibonacci 0, and we can print x, which is just going to be a single value in this case. Hit run, and it's going to print out 0. So if I wanted to say plus 4, now it's going to print out 5 because I added 4 to Fibonacci 0, and we'll cover that a little bit more when we get further along in these videos. But I just want to kind of show you guys how operators work and what we're doing here. So let's go ahead and uncomment these inputs here. So I'm going to say the area equals length times width, right? So I'm going to get inputs here, hit run. What is the length? It's going to be 10. What is the width? It's going to be 20. And you can't multiply sequence by a string, right? So again, these are going to be stored as a string. So what I could do is use one of those data type conversions, right? I could say I want to store it as a float, right? So I put all of this input inside of the float conversion, right? So you see this is my float data type conversion function. Put the input inside of it. Now the input will be converted to a float. So let's go ahead and do that for both of them and see if this works. Hit run. 10, 25.5. And, oh, I need to print out the area. Oops, my bad. Let's do that again. 10, 25.5. And it prints out 255.0. So that works. We just made ourselves a little area calculator. So let's go ahead and review what we covered today. So first off, we covered the print function, which we can print out either a number or print out, hello world, and then we can print out strings like that. So hit run, and it's going to print out those things. Second, we talked about variable identifiers. So those are like your names for your variables. Now, remember, we can name things they have to start with a letter or an underscore. So if I were to try to say first variable again, equals 10, this is going to give me a big fat red error. And errors are okay, by the way. I just want to make sure that's clear. If you get an error, don't be frustrated. It's just an error. It's just a friendly reminder from the computer that you can communicate with it right. You just it didn't quite understand, and that's okay. Sometimes, there's a communication breakdown. So don't be frustrated. If you wanted to use a number in that early on in there, you just put an underscore there, and that allows you to do that. So you won't get an error there. Also, if you want to do 2 words, you need to not use a space. You need to use an underscore instead of spaces. So don't use spaces. Don't start with numbers. Always start with letters or an underscore, and that will save you a lot of headaches. So let's go ahead and go over some of the data types again. So obviously there is an integer, which is just a whole number, and that's real valued, obviously. And then we also have floating points, floating points, which are numbers that have decimal points in them. So that's the key point difference between an integer and a floating point is the decimal point. So that allows you to have greater precision. Then there's also a string, and let's say Bob. So that is a string. And nope, automatically correcting the base string, which I do not want. Okay. So that's a string, and then we also talked about lists today. And we talked about tuples and dictionaries, but we didn't really cover them in this video. That will be again, that's a video later on, and those are really, really cool. But I didn't want to spend 20 minutes on this video. Or I'm already close to 20 minutes, but 30 minutes on this video. So, and again, a list, you use square brackets. So each item is separated by a comma. So whatever you want to put in here, you could, and then you can go ahead and if you wanted to access those, you would have to say x equals list. You would have to use this index, and we'll talk about lists again later. They are kind of, they're not easy, but they are, once you get the hang of them, they're pretty easy. This is the first number in the list. So again, don't get frustrated if you're a little confused with what this means. All I'm at, it's the 0th index of this list, which would be 1 in this case, so x would equal 1. And in computers, things always start on 0. So it goes 0, 1, 2, 3, 4, 5, 6, not 1, 2, 3, 4, 5, 6 when you're counting up. So we also talked about some of the some data type conversions. So remember, when you ask for an input, like the height, you would ask for it. You'd say inputs and say, what is your height? And this is going to be stored as a string. So if you wanted to multiply, let's say you wanted to double your height, say height times 2, that's not going to work, because if we hit run now, and I say 10, well, it did work there. Oh, well, that's because height, you can multiply strings, right? So if I say print height, hit run again, 20, it's going to say 20. If I say print double, it's going to say 2020, which is not what we want. So we'd have to convert this using data type conversion. So I'd convert this to a float probably, so that I could maybe, do 20.5 if I wanted to. Say 20, and now it doubles it mathematically rather than like a string. So remember, when you can double strings, you can multiply strings, but it doesn't work the way you want to usually. You're not going to be, doubling the content. So that's about it. Again, we talked about variable identifiers, we talked about data types, we talked about inputs and outputs, we talked about printing, and we talked about data type conversion, as well as some operations. So we covered a lot of stuff today. Again, if you are confused at all, that is okay. We will be covering this throughout the course, and I will be repeating a lot of the things I talked about today. I just wanted to give you a big, broad overview of everything that you kind of need to know to get started. So the best way to learn this, again, is just to play around on your own and have some fun with it. So, all right, enjoy your programming.